This is a previous AIPMT question from friction. The problem is like this. A blockway is pushed momentarily with a along a horizontal surface with the initial velocity v. What's the meaning of that? There is a block was being named as b, doesn't make any difference. Pushed along the horizontal surface with the initial velocity v. There is a friction between these two. Coefficient of friction is mu. Mu is the coefficient of friction, sliding friction between b and the surface. Block B will come to the rest after how much time, right? So, as it is pushed this way, it will move forward. As the motion is forward, its frictional force try to act against the motion. How much is the frictional force is? Mu into normal reaction. What could be the normal reaction? Its weight is mg, assuming it has mass. N is normal reaction. So, mu into normal reaction is equal to mg. That's the force who is opposing the motion is opposing motion and develops force against motion. So what happens is then the body deaccelerates and finally stops. And that's what he's saying. Therefore, the retarding force acting is nothing but frictional force. M into A retardation equal to mu into mg. So A retardation here due to the friction equal to mu g. Right? Once if you got an acceleration, I can say v equal to u plus at. It is finally stopped, v equal to 0. U is given as v. A equal to minus mu g because it is retardation and time t. So mu g into time t equal to v. Time after which it stops is v by mu g. So after a time of v by mu g, the body gets stopped. So it's a very simple problem. And while you are solving the problem, you need to learn some basic aspects like when the motion is forward, frictional force is backward. Frictional force is mu into normal reaction. Normal reaction means block applies a force on the floor, downward action. Now the floor applies on the block equal magnitude but opposite direction, which is called as normal reaction. And the body is stopped because of frictional force, so acceleration into mass can be equated to frictional force. Simplified. This is how we solve the problem. Thank you for watching.